Dear students, I myself is Dr. Rajeshekar Reddy, Assistant Professor of Mathematics, Government First Grade College, Pavagada. Now we discuss third semester BCA Mathematics. In this we go for Unit 1 Matrices. In the previous sessions we have learnt about the basics in matrices, types of matrices and finding determinant of a matrix either 2 by 2 or 3 by 3, determinant of a matrix, adjoint of a matrix and inverse of a matrix using adjoint and its determinant. Then we discussed system of linear equations, homogeneous and non-homogeneous equations. Next we discussed the general method, easiest method of finding solution for system of linear equations, that is Cramer's rule. Then we discussed the system of consistent and inconsistent, the system of equations how that are consistent and when they are inconsistent, that also we discussed. Okay, in the previous class also we discussed about the system of equations when they consistent and when they inconsistent. The system of equations, if you write in matrix form Ax is equals to B, then first you write the augmented matrix A comma B. Already you know the augmented matrix is in a coefficient matrix A, the last column you include last column as constant matrix B. So in the coefficient matrix you include appending extra column. Which one extra column? B matrix. Constant matrix we append as a last column of the coefficient matrix, that is augmented matrix. Such augmented matrix and coefficient matrix, for such matrix we find ranks. When ranks are equal and equals to number of unknowns, it contains unique solution. When ranks are equal and less than the number of unknowns, then infinite solutions. When ranks are unequal, then it contains no solution. Now we solve the system of linear equations using this method, rank method. So you always remember the system of equations will have no solution when rank of the coefficient matrix and the rank of augmented matrix are not same. The system will have unique solution when rank of coefficient matrix and rank of augmented matrix are same and equals to the number of unknowns. The system of equations will have infinite number of solutions when the rank of coefficient matrix and the rank of augmented matrix are same and that rank is less than the number of unknowns. Now generally we discuss a system of linear equations is consistent or not. Let us take a problem. 2x, system of linear equations, 2x plus 3y plus 2z is equals to 3, 3y plus z is equals to 0, x minus 2y is equals to 1. So first we write the system of equations in the form Ax is equals to B. So the coefficient matrix is 2, 3, 2. In the second equation there is no x term, that's why x coefficient is 0. So second row is 0, 3, 1. In the third equation there is no z term, that's why z coefficient is 0. That's why the third row is 1 minus 2, 0. And unknown column matrix capital X is equals to x, y, z. Next, constant column matrix B is equals to 3, 0, 1. Now let us construct an augmented matrix. Augmented matrix A comma B is equals to matrix of elements 2, 3, 2. These are the elements according to first row of the coefficient matrix. Now we include constant matrix as a last column. That's why, so 2, 3, 2, last column element 3. Second row is 0, 3, 1, 0. Third row 1, minus 2, 0, 1. Using echelon form. Echelon form is the form to find out the rank very easily. That means in each column the number of zeros appear should be below the non-zero element. The number of zeros in any column should appear below the non-zero element. So in echelon form the second condition is in any row the number of zeros are in increasing order. Number of zeros are increasing order. So in echelon form rank is nothing but the number of non-zero rows. The number of non-zero rows is called the rank in echelon form. If 0 row, while finding rank in echelon form, 0 row exists. That means all elements in a row is 0. That should appear in last row. It is the last row of the matrix. So while constructing the echelon form, you should remember that zeros appear in any column, that zeros appear below the non-zero row. When row number increases, number of zeros also in increasing order. So in that way the rank is number of non-zero rows. Okay, here we constructed an augmented matrix. For the augmented matrix, second row first element is 0. So here first row element is 2, third row element is 1. If you want, you can make interchanges. So R1 and R3 we can interchange. Without interchanging also we can use, so 2 below element 0 is there. The third element in the first column, the third element we make 0. That's why using row operation we have to make the third element in first column becomes 0. Like that we have to prepare in second row also. In second row the elements below second row we make it 0. Like that in third row also the elements in third element becomes 0. So while constructing the echelon form, you should remember that the elements below the first column in first row, first column element you choose and make all the elements below the first element is 0. Next in second row second column, all the elements below it is, we make that 0. Like that in third row third column also the elements below such elements make that 0. So while constructing the echelon form, you should aware of 0 row appears, it occur only, suppose either first row contains 0, you interchange. So last row as first row as last row. Like that 0 row appears, it should be in last row. Next, when row number increases, the number of zeros also in increasing order. Like that we have to prepare echelon form. So in augmented matrix, make that all the elements below the first row first column element make zeros. Like that in second row second column all the elements you make that zero using row operations. So such that if you prepare you get rank of augmented matrix. So we got that all the elements below the first element zeros, all the elements below the second element second row zeros. Like that in third row also all the elements below third row third column element becomes 0. So converting into echelon form, observing we say that rank of augmented matrix is equals to 3 and rank of coefficient matrix also 3 and number of unknowns also x, y, z 3. Hence the system is known as consistent and it contains unique solution. So any system of equations to prove that inconsistent, we find the augmented matrix and their ranks, rank of augmented matrix and rank of coefficient matrix. Rank of augmented matrix is equals to rank of coefficient matrix, then the system is consistent. Whenever these two ranks are not equal, then the system we call that consistent. Like that we can solve this system of linear equations using matrix method, whether the system is checking consistent or inconsistent. Based on that we can give clarity about solutions, number of solutions, either it contains unique solution or more number of solutions or no solution.